Hello everyone. Today we are going to deal about the next topic called duality method. Duality method. Okay. Now in LPP, every primal problem has an equivalent dual problem. So they exist in pairs. If there is a primal problem, it will have a dual problem with the same set of data. So if primal problem is maximization, the dual will be minimization. If the primal problem constraints are less than or equal to, the dual problem constraints will be greater than or equal to. So if the number of constraints in the primal problem is 3, then the number of variables in the objective function of the dual problem will be 3. Okay, similarly like that, it's just the opposite of everything. And if you try to solve the dual problem, you will get the same solution if you try to as the solved solution of the primal problem. So we will see how it is done. Suppose there is a problem like this. Minimize z is equal to 12, I'll write 12x1 plus 8x2 subject to 8x1 plus 2x2 greater than or equal to 24, 18x1 plus 2x2 greater than or equal to 20, 14x1 plus 6x2 greater than or equal to 18, 20x1 plus 80x2 greater than or equal to 40, x1 comma x2 greater than or equal to 0. This is the problem that you have. Now we have to convert this to dual. So when you write it, what you do, we'll write it in this side itself. You can see there are two variables in the objective function. That means in the dual part, you will have two constraints. Now there are 1, 2, 3, 4 constraints in the primal. Then there will be 4 variables in the objective function of the dual. Since this is greater than, it will become less than, and the right hand side will become these two values for the two constraints, and these will be the values of the variables in the objective function. So we will write the dual is going to be, we will use a variables instead of x1 x2, we are going to use the variables y1 y2 y3 in the dual problem. So minimization will become maximize z is equal to, what you're going to write is, you will have, there are 3 constraints, so you will have 3 variables, so it will be used with these. So it will be 24 y1 plus 20 y2 plus 18 y3 subject to, because there are 2 constraints, 2 variables, you will have 2 constraints in the dual, and the values will be, you will take it in the column form. Okay, so it will be 8 y1 plus 18 y2 plus 14 y3. Since this is greater than, it will become less than 12. Okay, again the second constraint will be 2y1 plus 2y2 plus 6y3 less than or equal to 8. And now the values will be y1 comma y2 comma y3 greater than or equal to 0. So you have got one equivalent problem for this problem, and the original one is called the primal, and the equivalent problem is called the dual problem. So the features are, if the primal has n variables and m constraints, here there are 2 variables and there are m constraints. How many constraints? 3 constraints. 3 constraints. Then the dual will have the dual will have, this is n, this is m. The dual will have three variables and two constraints. So it will have m variables and n constraints. So now what we have is opposite of it. The next feature is, if the constraints are all less than, it will become greater. In this condition it is greater than, so it will become less than. If the objective is maximization, then it will become minimization. In this particular example, we have the objective as minimization, so it will become the opposite, that is maximization in the dual. Then for every primal constraint, there are three constraints. There will be a dual variable. See, 1, 2, 3 constraint. There's one constraint, two constraint, three constraint. For three constraint, there'll be three variables, y1, y2, y3. And for every primal variable, there will be one constraint in the dual. So you have two variables, so you will have two constraints in the dual problem. The inequalities will be reversed. So this is very simple. Now, as an assignment, I would ask you to solve this problem and also this problem and check whether the answers are same. So that is the assignment for today. Next, we are going to deal with inequality of constraints. Now, we have studied that in a maximization problem, all the constraints should be less than or equal to, and in minimization, all the constraints should be greater than or equal to. But in some cases, we have constraints which are of mixed type. That is, we will have both greater than and less than in a maximization, and in minimization, we will have both greater than and less than also. In those cases, what you have to do is multiply by -1 on both the sides to get it to the required sign of the constraints. For example, let us see a problem. Maximize z is equal to 4x1 plus 3x2 subject to 2x1 plus 3x2 less than or equal to 16, 4x1 plus x2 greater than or equal to 10, x1 comma x2 greater than or equal to 0. This is a problem. So since this is maximization, we expect all the constraints to be less than or equal to, but we have only one constraint which is less than or equal to. So to convert this one to less than or equal to, we multiply this constraint by -1 on both the sides. So now this will become minus 4x1 minus x2 less than or equal to -10. And we can write this one also here, 2x1 plus 3x2 less than or equal to 16, and the same maximization problem. So now this you can convert to the dual. How this will convert to minimization? Since this is maximization, this will become minimization, and you have two constraints here, so there will be two variables also. So you can write with these two values. So it will be z is equal to 16y1 minus 10y2. Okay, and you will have subject to the constraints. Since there are two variables in the objective function, there will be two constraints in the dual function. So it will be subject to with these values, 2y1 plus 4y2. Since this is less, both are less than, minus 4y2. You should look into this one. Minus 4y2. I will just change this and write it. I don't want to confuse you. I'm going to change and then write this. So this is minus 4y2. And since these two are less than, it will become greater than or equal to with the value 4 for the first one. The next one is going to change to Next one is going to change to these two values. So this will be 3y1 minus y2 greater than or equal to 3. Greater than or equal to 3. Where y1 comma y2 greater than or equal to 0. So you have an equivalent problem for this. This is the primal and this is the dual. Normally we used to solve this. Some cases when the number of constraints are more, it will become difficult. So when you convert it into the dual, the number of constraints can be minimized, and hence solving the problem becomes easy. Not in this particular case. Again, we will do another problem. We have another problem. Let's see. Minimize z is equal to 4x1 plus 2x2 plus x3 subject to x1 plus x2 less than or equal to 10, 3x1 plus x2 plus x3 greater than or equal to 23, 7x1 minus x2 equal to 6, x1 comma x2 comma x3 greater than or equal to 0. Now we can see this is a minimization problem. Obviously, since this is minimization, all the constraints should be greater than. But we have only one constraint that is greater than here, and the other one is less than, and the next one is equal to. So what you can do is, this is easy, you can multiply this with minus 1. So multiply this constraint with minus 1, this will become, 1, minus 1, it will become equal to minus x1 minus x2 greater than or equal to minus 10. Now, but there is another constraint here which is equal to. In these cases, when there is an equal to sign like this, 7x1 minus x2 equal to 6, this gets converted to two cases. That is 7x1 minus x3. What did I write here? This was x3. Okay, this was x3 minus x3 greater than or equal to 6 and 7x1 minus x3 less than or equal to 6. This is the equivalent of this. So if you write like this, it will become equal to 6. Okay. Now you use this in the original problem. So in the original problem, this is correct. Now this one we have to change. So you have to multiply this with minus 1. Multiply this with minus 1 and it will become minus 7x1 plus x3 greater than or equal to minus 6. So I'll write down the constraints again. All the constraints. You have the first constraint will become minus x subject to minus x1 minus x2 greater than or equal to minus 10. The second constraint was fine. We can write it like that itself. 3x1 plus x2 plus x3 greater than or equal to 23. Then we had, instead of this one, we have written 2. First is this one and the second one is this one. So this will be 7x1 minus x3 greater than or equal to 6, and the next one is minus 7x1 plus x3 greater than or equal to minus 6. And I'll write the problem also here. Minimum of z is equal to 4x1 plus 2x2 plus x3. So this is the problem that we have. Now you have to convert this to minimization. Now it is easy to convert because we have the inequalities have been changed. The equalities also have been changed. Now we'll write it. We will get it as the dual is maximize z is equal to, since we have 4 constraints, we will have 4 variables here with these values. So this is minus 10y1 plus 23y2 plus 6y3 minus 6y4. Based on these, this will become the coefficients of the variables. The number of variables will depend on the number of constraints. Subject to, since we have 3 variables here, there will be 3 constraints in the primal, and the values will be taken column wise depending on x1s, x2s and x3s. So we will take the first x1s, that will be minus y1 plus 3y2. Then we have plus x7, so it will become plus 7y3 minus 7y4. This is greater than, so it will become less than or equal to with the coefficient value as right hand side value as 4. Okay. Now the next one will be based on the x2s. So you take the x2s. Here variable is x2. So the variable is x2. Here the variable is x2. So you take the x2 values. You have only 2 x2 values. Okay. So you write minus y2 plus minus y1 minus y1 plus y2. There are no x2 variables here, so you're leaving that. The greater than, so it will become less than or equal to with the coefficient value 2. So this will be right hand side value 2. Now you have to take for the third variable, that is x3. So you take the x3s here. Okay. So it will become, so you see here x3 in the first constraint you don't have x3, so there is no y1 variable. The second one you have an x3, so that will be y2. This is for y1, this is for y2, this is for y3 and this is for y4. Okay, so y1 variable is not available. So there is one here x3, so that is y2. So you can write here as y2, you have one here minus y3, you have one here plus y4 less than or equal to the coefficient of the minimization third variable, that is 1. Okay, and then you write y1 comma y2 comma y3 comma y4 greater than or equal to 0. So you got the dual for the ML problem. So we have done with the normal case, then we have done with inequalities, changing it into the desired equality, but changing it to the desired sign, not equality, by using minus 1, multiplying the with minus 1. And if you have equality, you convert it into both greater than and less than, and change one of them by multiplying with minus 1. So you have got the dual.